So today's topic will be NATing, network address translation. What is network address translation and why do we require it? See, whenever you have, for example, if I say you have a design like this, you are in your home environment and you are sitting over here and you want to go and surf the internet. How will you go? See, you as of now use private addresses. We use private addresses at home, 192.168 range, but on the internet these private addresses are not allowed. The ISP, if you give a private address over here, it can be assigned, but your ISP will filter that address. You cannot go on the internet if you have a private address on this side. So if you say I have a WAN segment, this area will have your public addresses. Internally, your ISP will also have a private network. That is why he will filter your private addresses on this boundary. So over here, you have public addresses. Over here, you have private addresses. But for you to go outside, how will you have a public address? That is what your router sitting on the edge will do. This router will do something called network address translation. What network address translation? Translating this private address with the public address on the external side. In NATing, you have two sides. One is the inside. This is inside is your private network, and obviously this will be the outside. So you have to tell your router that I want to have NATing and these are my sides, internal side and external side. So this is how you can go on the internet by using a private address. You have a private address and it is also used as a kind of proxy, you can say. One thing is your internal network is safe. Outside people don't come to know that they are coming inside, and your network is hidden from outside. The first thing is this, and you don't have to buy many public addresses. See, if you have 3 PCs over here, every PC requires a public address, but in NATing, we save the amount of public addresses that we want. The first thing, we are learning all this subnetting and all because IP addresses are depleting. There are not enough IP addresses so that everybody can take. That is the reason they came up with IPv6 also. So let us design this network. We will have a small topology like this, and here I will keep a testing PC. Assuming that there is a server or something, or there is a testing PC. Let us implement this. So what will be the configuration? This we will give the IP address range of your private range. You can say 192.168.1.0/24. And here I will give 1.1.1.0/24. Here we will have same 192.168.2.0/24. So assuming that this is the public side and this is the private side. So let us give the basic IP addresses. What will be the configuration of your router 1? We are talking about this router over here, router 1. This is enable configure terminal host name router 1. Interface gigabit 0/0 IP address 192.168.1.1.255.255.255.0. No, shut it down. We turn this interface on, and then interface gigabit 0/1 IP address 1.1.1.255.255.255.0. No, shut it down. So the difference over there and here is that you have to specify on this interface gigabit 0/0. You have to say IP NAT inside. This is my internal network, so you have to specify IP NAT inside on this one. And the external side over here on the gigabit 0/1, you have to say IP NAT outside. These are the very basic requirements of having NATing. But we'll do the NATing later on. First, I will have communication from end to end. We have to have this PC pinging this PC first. Then we will do the NATing. So let us give this basic IP addresses, and with this you will also require a routing protocol. How do you have reachability from here to here? These routers must have the route. You can use static route, default route, whatever, no problem. So I will use just a routing protocol. I will say router EIGRP1, no auto summary, network 0.0.0.0. Simple. I am establishing neighborship with my other router over there. So simply I'll copy this configuration and I'll paste it on router 1. and enable configure terminal, both interfaces IP address, IP NAT inside, no shutdown. I turn this interface on, then interface gigabit 0/1 IP address, IP NAT outside, no shut. Protocol working fine. So let us say copy, run, start. Saving this configuration. Now I will go here and assign the IP addresses. What will be the address? It should be 192.168.1.2. Gateway is 192.168.1.1. Similarly over here, 192.168.1.3, 192.168.1.1. Here it will be 192.168.1.4, 192.168.1.1. So I have connectivity from here till here, and here also I did the configuration. Let us configure the router 2. What should be the configuration of your router 2? It will have a host name of router 2. His gigabit 0/0 goes over here. So his gigabit 0/0 will have an IP address of 1.1.1.2. And no NATing on the other side. There are around 11 or 12 types of NATing, reflexive NAT, dynamic NAT, but we have only 3 for us. Internal interface is 192.168.2.1 and no NATing in here. See. So this is the very basic configuration. This is just the testing part. This is where we are just simulating a network, but actually the NATing will happen on this side. In advanced stuff, NATing happens on both the sides. But so what is the configuration? Host name, interface addresses. That is it, nothing much. So let us copy this one and let us paste it over here. No copy and start required, but I will assign an IP address over here now. So I'll go on the desktop, 192.168.2.2, 192.168.2.1. Let us see, can I ping from here 2.2 till 1.2? Ping 192.168.1.2. First packet should timeout. Second packet must give you a reply. So if your configuration is correct, you get a reply from the other side. Let us see now. Now is the NATing part. NATing part means here you have given 2 statements. You have just told the router IP NAT inside and IP NAT outside. But you have to merge both of these. You have to inform. Now the first type of NAT that we will see is called static NAT. Static NAT is 1-to-1 mapping. Means if you have 3 PCs in here, you will require 3 public IP addresses over here. This can be done in a demilitarized zone or something else. If you have a web server, he requires 1 static IP, then you can use a static NAT concept. But static NAT is not useful very much. Why? Because, just a moment. Why? Because in your static NAT, you cannot scale it well. Let's see, you have to do 1-to-1 mapping, and if you have 100 PCs, 100 public addresses will be required, I think. Yeah. So how do you do that? You should be in the global configuration mode. You have to say IP NAT inside source. IP NAT inside source static 192.168.1.2 1.1.1.1. Means what am I saying? IP NAT, when the inside goes outside, when this internal part wants to go outside, kindly bind him statically. This is your private address in internal, and give him this address of the outside network. So this network must be over here. This will be your public address that your ISP has given you. So this is the first part that I gave it. I told him that gigabit 00 is your inside, 01 is your outside, and now I will do the binding statement. How do you do the binding statement? Simply go on the CLI and configure terminal and IP NAT inside source, static mapping. This guy is statically mapped with this guy. Clear? So let us test. Now assuming that this is the internet cloud, this guy wants to go outside. If he has a public address, then only the data will be coming outside, right? So let us ping from here. If I ping from here, Earlier, 192.168.1.2, he himself was replying. Now, see who gives me a reply. I wanted to go to one public IP address, for example, and he gave me a reply. See, I am pinging 1.2, but who is giving me a reply? 1.1. This is the effect of NATing. Network address translation happened on this one. How will you test on your router? You can simply say show IP NAT translations. In here, it will tell you that there was a protocol that was ICMP, because ping uses Internet Control Messaging Protocol. This is the internal private address, and to him I gave this public address. These are the port numbers. But as of now, just see inside local and inside global. This is outside local and outside global.